All right, so I think I'm recording. We are looking at skill packet 5, which is exponential and logarithmic functions. And in this skill 5G, we're solving equations. And the last few problems in this on this day 2 skill 5G are a few application problems. It gives us a function that is modeling something where the input and output mean something. And we're just replacing the left-hand side with a number set then solving an equation. So here it looks like they have some type of a lake that is stocked with bass, and the population of the bass in the lake after t years is modeled by the function, by this equation, by this function. And probably it would have been smarter to have given it as in function notation, that the population as a function of time, that the population of this fish in the lake, this bass, changes over time. And we can input the number of years after its initial measurement. Now, we're just taking faith that this is an accurate model. Typically these models, your t equals 0 is your initial value. So let's see, according, does it make any sense? And I don't think it does in this case. 1 minus 4 e to the 0, that's a negative number. So in a way, this sometimes happens, that this model may not be very good at the very beginning, or after so many years. There'll be a limiting factor to where there's only so much food and only so much room in the lake, and the lake can only support so much life. It doesn't just keep growing without bound forever. And initially, using this function doesn't make sense to think about how many fish were. Maybe it was a man-made lake, and initially they populated it with, 100 bass or something like that, and then they want to know how many years will it take for that initial amount to grow to 1,000 is what it looks like. So the left-hand side is the amount of fish, the population of fish, and it wants us to solve for t, the number of years that it takes for the population of fish to be 1,000. So that sets up this equation. And we've seen equations like this before that were in the previous problems. The term of interest is down here in the denominator, so we've got a ways to go to get there to try and get that term by itself. So I would set it up as 1,000 over 1 and set it up as a proportion. On the right hand side we have a fraction, and now on the left hand side we have a fraction. We can solve proportions. A common technique that students seem to like is to cross multiply. We can multiply along this diagonal, and then we can multiply along this diagonal and take those products and set them equal to each other. So the 10 times 1 is 10, and 1,000, we need to distribute this 1,000 to both of these terms. Alright, so let's do that. Let's see, 10. The first term, 1, gets multiplied by 1,000. And the second term gets multiplied by 1,000, so that 4 becomes 4,000. And now on the right-hand side I have two terms. The term of interest that I want to get by itself is this guy. So let's subtract 1,000 from each side. Positive 10 minus 1,000 is negative 990. Both sides are negative, so I can just multiply by a negative number and change those to positive. And on the right hand side we have two factors. The factor of interest has my variable t, so let's divide both sides by 4,000. And we can simplify it. our fraction by a tens cancel. So instead of 4,000, I've got 400. And I've gone as far as I can go with just our normal properties of equality. I'm going to take the natural log of each side and use the power rule in order to get this variable down as a coefficient so I can get it by itself. So if I take the natural log of the left-hand side, to balance the equation, I have to take the natural log of the right-hand side. I'm going to put my variable on the left. I do it out of habit. It's just, whoa, let's shrink the whole thing up. So using the product rule, this negative 0.8t comes down. The natural log of e is just 1. And I've got the natural log of 99 divided by 400. Now, that's a bad looking t. I need to get that t by itself. It has two factors. I need to divide both sides by a negative 0.8. So I've got this natural log of this fraction divided by this negative 0.8. Let's get an approximation for that. That no one's going to like it if I give that to them and say the number of years later that it will take the lake to reach 1,000 bass in it is natural log of 99 over 400 divided by negative 0.8. They're going to look at me like, are you nuts? All right. So the natural log of 99 divided by 400 divided by negative 0.8, 1.7. So in a little less than 2 years. I'm not going to probably tell somebody quite 2 years. That's not like a 1.99 or something, in a little less than 2 years. All right, so hey, I hope that helps. I believe that's the last one, and I will talk to you later. Bye.